Okay. Yeah, guys, please, as I said today, we're going to talk about the properties of the logarithmic functions. And please take notes of every single, I should say, discussion that we're going to have, because you're going to use these properties over and over again. Even if you just go to advanced functions, you just go to, for the calculus course, you use that in chemistry, you use that in physics, you use that in economy, then just make sure that you do a great job for today's session. And we talk about, I should say, the properties of the logarithmic functions. Okay. Guys, if you remember, we talked about a two-way definition. We said that when we say about the exponential function, we said that if we talk about the b, and b goes to g of x, which is a function of one single variable of the x, then you notice that before that you can define a function as f of x. We said that f of x is a function which is exponential because the function which is a transformation of the x appears on the exponents or the power of a single base, which the base can be any real number. As you remember, b should not be equal to 1, and b has to always necessarily be a positive number. And at these discussions which we have, that we call that the exponential function. We said that from the exponent function, we can make a two-way street. And what do I mean? I said that we can also define this to say that the, sorry guys, we said that the log of, let's say, the f of x with the base, which is going to be b, correct guys? What does it give me? Remember it, guys? What does it give me? Do you remember? It gave me g of x, correct?
Yes.
Yes. Then essentially you learn that the logarithm of a function always gives me the exponent of an exponent if you transform it from logarithmic function into an exponential functions. Any questions on this, guys?
No.
No? Okay, nice. And now we are just going to discuss about the first property. We discussed about that also before, but now we're going to talk about that, I should say, collectively with five more properties of the logarithmic function. The first property is this, and you learned that before, that the log of 1 at any arbitrary base is going to be what?
0.
What?
0.
0. Why?
b power to 0 is equal to 1.
That's so true. Because whenever, guys, you are confused why these things happens, simply you can transform it to the exponential format. As you remember, we said that you start, we said that you start from b. That's correct. Then you move to the back seat, which is going to be 0. It gives you what? The driver's seat, which is 1. Do you remember that the way which we were working with this? A couple of, I should say, sessions before? Yes, guys?
Yes.
That's right. Then we always said that when we just want to work with this stuff, we move from the backseat driver, we go to the 0, and from the 0, we go to this. That's why I write it. b to the power of the 0 then becomes 1. That's property number 1. Any questions, guys?
No.
No. It's a very, I should say, handy, useful property out of 6 properties that we're going to talk about that today. I call this what? Property Property number 1. You see that? Okay. And now, the second property that we are going to discuss is going to be, we saw that before. We saw that, for example, when we said that, for example, the log of any number, for example, I call that, let's say, b, and also the base is b at the same time. You remember that? We said that, what is that going to be, guys?
1.
1. And if you wonder why that property holds, you can always show how it's written in its exponent form. You say that, okay, it's b, that's b to the power of 1, becomes how much? Becomes b. That's why we say that this property holds that the logarithm of any number with the same base, it's always equals to 1. Correct? Is it clear?
Yes.
Yes.
Nice. We call that property number 2. Okay. For property number 3, we have also talked about that before. That's now, it's a kind of a review for property number 3. For property number 3, if you remember previously, we said that the log of, let's say, a with the base, which is going to be b, but the thing which is going to be different now is that in this case, we have, let's say, a is the power of the n, which equals to what? Do you remember that, guys? What's that going to happen? Do you remember it?
It's n log b power to a.
That's right. For example, why is that going to be? Imagine that, for example, A is Rose, which she is driving a Lamborghini, and this is Philip sitting next to her, and Gloria is looking at them. And imagine that while Rose is driving so fast, because the wind is blowing to his hair, just Rose is driving so fast, it takes off the hat from her head and pull it back before the car on the gun of the Lamborghini. And that's why when we have this case becomes n to the log of what? A, the base remains b as it was before. Correct? We are going to use these properties a lot today. And it's good that you should be up to the pace of the sessions before we move on to use these ones extensively. I call this one property, what number? Number 3, correct?
Yes.
Awesome, guys. Any questions so far?
No.
No questions? Okay, let me take a look at my notes to see where did I the property number 4, because at these sessions, your sessions with the advanced function class is very overlapped. Until tomorrow, your sessions with the advanced functions is almost the same thing. But after tomorrow, you have different contents. They have a different context. Okay, now, the other property, which is going to be our property number 4, which is going to be something which you have to do that as a homework to prove that, is this one. I say that, for example, if I have a base, okay, and the base has as an exponent, guys, you see that? It has a log as an exponent, that the exponent has x, but the base of the logarithm also is b. Okay? Then do you know what is that going to be? Any guess?
Yes.
It's going to be x. It is very useful, guys. We're going to use that a lot. But please use, that I should say, the properties of the exponents. I mean, this property that they can move from a log function, go backwards to deduce the exponent form, or vice versa, from the exponent forms, move to get the logarithm function. Please use this property and try to prove this identity. And please submit it to me on the Schoology website, and that's what we are going to do. Okay, please take that as a homework. Then it becomes my property number what? Property?
4.
That's right. Property number 4. Then guys, this is going to be part of your homework. You submit that tomorrow before the class. Then to prove this identity, please. Okay.
Okay.
And now guys, we are going to talk about 2 other properties which are going to be essentially the building blocks of the thing which we're going to do today. But any questions so far? Any questions? No. Okay, let's move on. I'm going to write, I should say, other property. This property is this. I say that the log of now 2 functions. One of them I'm going to call this f of x. The other one I'm just going to call that g of x. They are multiplied together and they share the same base. Okay, you can see they are the product functions. They are multiplied. F of x is one representation of the x, and g of x is another representation. What I'm going to do is that I'm just going to put the log of f of x, the same base which I had, plus, I'm going to explain why it's going to be like that. Just give me 1 second. The log of g of x with the same base, which is going to be my property. I'm going to explain to you why, what does it mean? Okay, guys, what does it mean? Look at that. What did I mean by that? And essentially, in the lane terms, guys, that we talked about that so far, we said that, guys, look at that. Imagine the log functions which I have on the left side equation is become like the Lamborghini car which we had. Imagine f of x is going to be Gloria. Gloria, are you still there?
Yes.
And g of x is going to be Rose. Okay. Both of them, they are sitting at the front seat of the Lamborghini car. Both want to drive. And B is also Philip. Philip is sitting on, I should say, on the passenger seat at the car. But guys, look at that. At the front seat, there are 2 people sitting, Rose and Gloria. And they are going to fight because one of them says that, no, I want to drive the car. The other one says, no, I want to drive the car. Huh? And Philip is watching them. But what's going to happen now? Philip says, okay, stop fighting. Rose and Philip, stop fighting. What do? I give you, each one of you, a Lamborghini. You see? I give Rose, which was f of x, a Lamborghini. Philip is sitting. And also plus, I give Gloria another Lamborghini, another Lamborghini with the same passenger, which is Philip. You see, you do not have to fight when you both are sitting at the front I should say, driving seat. You can, each one of you has a Lamborghini. But aside from this story, this property is saying to you that if you have a log of a product of a function, okay, what do? You decompose them into each one as a log. Log of one function plus log of the other function. Okay? Any questions, guys?
No.
No? Okay. If you have no question, then what I'm going to do is just gonna close this one, give you an example about the log functions. To tell you what do I mean, I bring you an example, then we move on to the last property. Which property is that going to be? Property number 5, correct? Okay, now I'm going to give you an example specifically for this part. Guys, look at that. I'm going to tell you the log of, I'm going to give you two functions. The f of x is going to be, imagine that, it's going to be x squared, okay? And the g of x is going to be what? The square root of x plus 1. The base, keep the base, for example, as b. It can be whatever. Guys, can you see that? Yes?
Yes.
Awesome.
Yes.
What's going to happen right now? Look at this. Match this with the property which we talked about. We said that the log of two functions that they are multiplied. Imagine x squared is my f of x. The square root of x plus 1 is g of x. And they are clashing, they are fighting because both of them are sitting at the front driving seat. Then what do? I come to decompose them. I say the log of, let's say, x squared with the same base plus the log of the same, I keep the base the same, but I change this one to what? To the g of x, which is a square root of x plus 1. You see how it worked? I only decompose this product into the sum of two logs. Huh? Make sense? Do you have any questions, Anna?
Yes. No.
No? How about you, Gloria and Philip?
No.
Everyone's fine?
Yes.
No.
Yes.
Philip,
Yes.
are you okay?
Yes.
Awesome. And now, guys, before we move on to do some more interesting stuff, I'm going to give you the very last property. This last property is going to be very essential for whatever we do in the next sessions. The last property is this. Imagine that for this one, I say I have the log, but for this one, instead of making the products, I'm going to do what? I'm going to make, let's say, a ratio of two functions. Imagine that now this is f of x, which is on the top, and I have my g of x at the denominator, correct? And I'm going to have my base be here. Okay, what's going to happen to this? Previously, guys, in the previous property, the thing which we had was that we had two functions multiplied together. We decompose them into the sum. And now for this one, I have two functions which the log is acting on it, but they are divided by each other. You see that? Then the thing which happens is that the result is going to be this. Then you say that it's decomposed them into the log of two functions. I keep the base this, and I take the f of x like that, but I say it becomes minus of the log of g of x with the base which is going to be what the base is going to be. Yes? You see that when two functions are divided in front of the log function, that's right, you decompose them into the difference of the logs of each function. You see that? I'm going to give you one quick example on it. Then we move on to do more complicated stuff. What property is that? Property number
6.
6. That's right. Property number 6. Okay, I'm going to give one quick example on it. Then we can do more exercises. Okay, let's, if I write here, you see that if I write here?
Yes.
Okay, nice. Guys, look at that. I said the log of these two functions. I say x squared over x plus 1. Base can be any b. Guys, do you see that or? Yeah?
Yes.
Awesome.
Yes.
Then guys, look at that. I have the same example. You see that in front of the log? I have a function, which that function itself is, look at that, we can think of it of a function divided by another function. I know that if that's the case, I can decompose my function into the difference of those two logs. Becomes log of x squared with the base b minus the log of the denominator, which is going to be x plus 1 with the same base. Correct?
Yes.
Guys, do you have any
Yes.
questions?
No.
Are you sure?
Yes.
How about you, Rose? How about you, Gloria?
No.
How about you, Rose?
No question.
Awesome. Guys, now then what we did so far was that we reviewed on the definition of the log and exponential function. Then we introduced 6 properties. And now, what are we going to do? I'm going to give you 3 examples that you're going to use each individual property to simplify that expression. Let me find those functions which I have. Okay. Let me put this aside. Do the exercise. Okay. Okay, the first function which I have is going to be this. I say that as a first example. I'm going to give you this function. I'm going to ask you to please do this one. The log of the function which you have is going to be the square root of x plus y divided by 10. Okay. The next function is going to be the log of x, y to the power 3 divided by z squared. The next function, which I'm going to ask you to do, please, it's going to be the log of square root of x to the power 4 y z to the power 3. And this one is going to be, let's put it 5. Okay, let me think of the last one. Oh, I got something interesting. And the last one, which we're going to talk about today, it's going to be this function. Give me a second. Oh, this one is going to be great. The log of x plus 1 divided by y squared square root of z. Guys, are you still there?
Yes.
Yes.
Awesome. What time is it now, by the way?
30.
30.
6:30. Oh, wow, that's great. We have lots of time. Guys, I have these 6 questions now. Please write them individually. And based on the 6, I should say, properties that we learn, please try to give it a try to see if we can simplify that as much as you can. For example, remember on the examples which we did, for example, for property number 5, we said that the log of x squared into the x plus 1, it can be simplified to that. Huh? You also please try the same thing to see that if you can use all these 6 properties to simplify these expressions as far as you can. Then when you are done, I do that one by one for you. You can just correct your answers. Okay, do you see all these exercises? Yeah?
I can now see the first question clearly.
How about now? Log of square root of x plus y divided by 10. Everybody sees these exercises clearly? You know what's written there?
Yes.
Yes? Yes, you said yes? Rose?
Yeah, yes.
How about Gloria?
Yes.
How about Philip?
Yes.
How about Ferris? Okay, guys, then if it's fine, just spend a couple of minutes, 5 minutes, then I come back to do that one by one with you. I'm here. If you have any questions, please ask me. I'm not going to work it for 5 minutes, give you some time to just work through them. Guys, are you done now? Hello?
Not yet.
Not yet.
Not yet. No worries. Wherever you are now, please just stop. We just do one by one. Then it's much more effective than I keep you, leave you on your own. Okay. I'm just going to start with number one. What did I have? I had the log of square root of x plus y divided by 10, correct? Guys, for this exercise, what is the first thing which I can do? Look at that. I give you an example. When you just deal with these kind of problems. Guys, you know what is a house, huh?
Yes.
Yes? Have you seen those old houses? Sometimes they demolish it. They destroy it to make a new house.
Yes.
Yes? That doesn't make sense that when you want to demolish a house, just go into the kitchen and, for example, demolish let's say, a dish first, then it starts from small, then demolish the whole building. Or, give me 1 second, please. Or it makes sense when you want to demolish a house. Have you seen the cartoons that they demolish it by a huge, heavy ball? They hit the building and the whole building crashes. Have you seen that?
Yes.
Yeah? It's like that for here. When you're working with the logarithm function, you start from the bigger perspective, try to break it into small pieces. Do not go inside, let's say, y or x to, for example, to start working out with the small terms. Try to, like demolishing a house, start to demolish the whole logarithm at first. What do I mean? I mean that in most of the cases, you start working with properties number 5 and 6 at the beginning, because these properties, they are at the greater scale of the operation. They demolish the logarithm first. Then, for example, for this one, the thing which I can do is that I see property number 6, which it shows that what happens if two functions are divided, it's going to be more relevant, correct? Then the thing which I can do is this. I come here and I say this time, then this one can be written like that. I say the log of square root of x plus y minus the log of what?
10.
10. Correct. And now, guys, the other thing which we can do to simplify that further. What else can I do? So far, so good, everyone. Everyone got this one so far?
Yes.
I just used which property? For this one, I use property number. Which property was that I used now?
6.
Property number 6. Property number 6 allowed me to break this function to just reach to that point. But guys, I can just do something much simpler also. I can do many other things. What else you can think of? Please help me. What do you think? What can I do? Please, everybody says something. Give an idea. What can be the next step? Guys, are you there?
Yes.
Yes.
Look at that. The other step is that I see the square root. Guys, this one is very important. Please take good care of this one. I see the square root of x plus y, correct? You know that from let me write this here. You know that from, I should say, from previous courses, that if you have a base, and it has a power, but the power is like that. For example, it's a ratio. It's n over m. That's right. For example, 5 to the power 2 divided by 3. What is that going to be? It's going to be like that. You just keep the base, and whatever is, I should say, on the roof, it falls down to the base. Then n, if this is on the roof, it comes as a hat for the b. But what happens to the m? The downstairs, the denominator at the exponents? It becomes like that. It forms the exponent root of the base m. Do you see that?
Yes.
Is it clear?
Yes.
Yes.
Have seen that before?
Oh, yes.
How about you, Gloria?
Yes.
How about you, Philip?
Yes.
Everybody knew about that, huh? That's nice. Then when I look at this, I can just use that one. I can think of logarithm of x plus y, the whole function, as going to the power of 1. Does it make sense? Yes?
Yes.
It's actually, I'm doing nothing. I just put it to the power of 1. Then I know that the exponent of the, I should say, the square, the roots, it's 2. Is it correct? Then what can I do? I can come here and I just write this function only. I'm going to come here, write this function like that. I say the log of square root of x plus y becomes log of x plus y, all going to the power what? 1 over 2. Does it make sense so far?
Yes.
Yes.
Why? Because look at that, based on the thing which you said that you have seen before, I take 1 coming to, let's say, the numerator of the exponents, and 2, which is the squared root of that expression 2, I take 2 coming it as the denominator of the exponents, and x plus y remains where it is. Yes? If it's okay with everyone please say yes with so much confidence.
Yes.
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 I only heard from Philip.
Yes.
Yes.
And guys, say with confidence, yes.
Yes.
Ah, that's it. That's it. And now I can continue with the rest. And I can say minus log of 10. That's right, because I had also 10 there. That is correct. But now, it was property. Let me check my property numbers. I think it was property number 3, guys. Property number 3 says that whenever I have an exponent on the main driver of the logarithm function as a hat, the wind blows it off to the before the logarithm function. Do you remember it? Property 3. That's what I'm seeing it right now. I see that 1 over 2 is acting like an exponent of the main driver, which the wind is going to blow it off before the logarithm function. Then what's going to happen? It becomes like essentially equals to, I'm going to write 1 over 2, which is the exponent of the log of x plus y minus log of what? Log of
10.
10. Guys, can I continue further?
Yes.
How?
log 10 equal to 1.
Log 10 equals to 1. Yes, Rose?
Yes.
Okay. Let's see why log 10 equals to 1. Oh, because you mean that this is the base of the 10, huh?
Oh, yes.
That's right. Guys, do you remember that in the past, we said that whenever you do not write the base, it means that the base of the log is what?
10.
10, Rose. Thanks. How about you, Gloria and Philip?
10.
10.
Do you remember that rule that I said that whenever you do not write the base of a log, it means that this is 10? Do you remember it?
Yeah.
Then it means that this is going to be log 10. And based on what property was that? It was property number 2, that the log of b with respect to the b, when they are matching exactly each other, it's going to be what? It's going to be 1. Then as a result, if I see the log of 10 over 10, it means that the main driver and the passenger seat, they are exactly the same. And I can use property number 2 and replace it with what? With 1, correct? Then as a whole, it becomes what? It equals to 1 over 2 log of x plus y minus 1. Yes, guys, is it clear for all? Does it
Yes.
make sense? Do you need more explanations? Let me write it. Was property number 2. Guys, Philip and Gloria and Rose, does it make sense to all? Do you need more help, more explanation? Any part of this which doesn't make sense to you, I explain more? Hello?
No.
No.
Philip, are you okay?
Yes.
Yes. And Gloria, you're okay?
Yes.
And Rose, how about you?
Yes.
Fantastic, fantastic. If everyone is okay, please go to part number 2. Who is done with part number 2? Anybody's done with part number 2? Who finished this? No one?
No. Not yet.
Okay, I give you 2 more minutes, then I just come to just continue that with you. Based on the things which you learned from the first one which we solved, please give it a try for 2 minutes to see if you can apply the same concepts for log number 2. Guys, are you done now?
Yes.
Nice. Okay, let's do that together. Then we just take the break. Okay, this one is the log of, guys, can you please tell me what was the log? Log of
X power 2, xy power 3,
xy power 3 divided by,
z power 2.
okay, oh, great, thank you. Guys, okay, now, okay, let's start. Guys, please help me to figure this out. What is the first step when you look at this expression and it comes to your mind? What is the first step that you recommend me to just do in order to simplify that expression? Everyone, please say something. Don't stay silent. Gloria and Philip, everyone say something. Rose, what do you think?
Use the property 6.
Property number 6. Property number 6 was this formula, that the log of the ratio of two functions is decomposed of the difference of the logs of those functions, That's right. Everyone is okay with property number 6?
Mm-hmm.
Nice.
Yes.
Then, as Rose said, I'm going to use property number 6 to continue with this. What I'm going to say is that I'm coming down, I say, okay, it's going to be the log of x, y cubed becomes what? Minus of the log of z squared, correct? Which property is that? Property number
6.
6. Property number 6. Okay, now, what's going to be next? I see now, instead of one expression of the log, I decompose that into two expressions which both have the log. Then what's going to happen, guys? What's going to happen next? Which property you recommend me to use to simplify this expression further? Guys, don't stay silent.
For log xy power 3, can use property 5.
You mean for the first term?
Yes.
I use property number 5, Rose. Because
Yes.
I see that I have two functions as a product sitting at the driver's seat of the Lamborghini car. Then I say, okay, no worries, no fight. Each one of you are going to have a Lamborghini. Or the product, the log of a product of two functions is decomposed into the sum of the log of those functions. I said that in two different languages. The languages which is simply a kind of cartoon-like, the other one is more like the science-like in terms of the math. Then I'm going to use property number 5 to simplify the first expression. My first expression is this. No one can see that if I write here? Yeah?
Yes.
Then this one becomes the log of my first function is x, correct? It becomes plus the log of y to the power 3, and I continue with whatever is left, correct? Minus the log of z squared to the power 2. This one was property number
5.
5. Great. Thanks. Equals to. Guys, so far so good. Do you have any questions so far?
No.
How about you, Philip?
No.
Great. And now, guys, I'm at this stage. It seems that everything is neat, but there is one problem. What do you think? What that problem is? How can I just simplify that further? Guys, participate. Say something. Participate. Be brave. Say something.
Properties 3.
Property. I assume that you mean 3, huh?
Yes.
That's right. Guys, look at that. When you look at this, imagine each one of you, log x is going to be, for example, Philip, log y cubed is going to be Rose, log z squared is going to be Gloria. Each one of you is driving a Lamborghini. But Gloria and Rose, they are wearing some feather hat, and it's windy. You always remember, when you're wearing a hat, which is the exponent, 3 and 2, the wind, what does it do? The wind, the thing which it does is that it takes your hat, blow it before the car. Yes? Which is property number 'what property?
3.
3. Huh? Then if that's going to happen, then what happens is this becomes the log of the x, which is Philip itself, plus 3 times the log of y minus 2 times, which is the hat exponent of the other log function, log of what? Z. Correct? And here I'm done. I do not, can I continue further or no? I cannot do anything else, huh? There is no other property. I can just work with it to simplify that further. Log x, 3 log y, 2 log z. That means that that's the end. Nothing can be done further to process it, huh? And I'm done essentially. It's gonna be the final answer, which I was looking for. Guys, any questions on this particular example?
No.
Philip, you said you have a question?
No.
No? How about you, Rose?
No.
Thanks. How about you, Gloria?
No.
Thank you. Guys, if you have no questions, I think that's a good time to just take a quick break, huh? Then get refreshed. Come back in 15 minutes to continue with the 2 exercise which is left. Good? Sounds good?
Yes.
Nice. What time
Yes.
is it now?
703.
7:03. Guys, please come back by 7:18, huh?
Okay.
Cool?
Yes.
Awesome. Then I see you all back in 15 minutes. Enjoy your break, guys. Hello, guys. Anybody back?
Yes.
Gloria is back. How about Rose and Philip?
Yes, I'm here.
Rose is back.
Yes.
Philip is back. Awesome. Very on time, guys. Thank you. And now let's finish with these two, and essentially we should be done for the day. Okay, exercise number 3. Exercise number 3. Let's do number 3, which we have this as the log of. I'm going to write that as the square root of. What is the function, guys? Please help me to write that. It's x4. Am I right?
Yes.
Y z to the power 3, huh? And I think over there we had the power 5. Correct? That's a function?
Yes.
Awesome. Okay, guys, look at this one. Have anybody has done this? Anybody's done with this exercise?
Yes.
Are you done, Rose?
Yes.
Nice. How about you, Gloria and Philip?
Not yet.
Okay, no worries. How about you, Philip?
Not yet.
Not yet. No worries. We do that together. Okay, now, okay, the first thing, guys, when I look at this function is that what property you think is going to be more relevant if you look at the log function as a house that you want to demolish it, destroy it from the outside, like they have heavy balls, you want to hit it with the building that the building collapses. Which property is going to be more relevant for this? They had 6 property. Which one you think is going to be the best one?
Number 6.
Number 6. You mean this one, huh? That the ratio, the log of the ratio of the functions decomposes into the difference of the logs of the individual functions. That's right. Everybody is okay with that. Everybody thinks that the property number 6 is fine.
Yes.
Philip and Gloria.
Yes.
Nice. But guys, look at that. We are almost wrong. Property number 6 cannot be used right away. Do you know why? Look at these property which we have written. F of x over g of x. This one doesn't have any square root. These two functions are not under the roof of a squared function. Square root of a function, correct? This is f of x alone, this is g of x alone, and the log is acting on it. Yes? But the function which I have given to you, we have x4, which can be as f of x. We have y z to the power 3, which can be as g of x. But guys, the problem is that the difference which this one has with property number 6 is that I have the squared bracket inside the function. You see, it seems that the function is trapped inside the function, right? Then as a result, you cannot use property number 6 right away. The function is trapped. You have to make the function free from the squared root, then use property number 6. Everyone is okay so far? You understand what I'm talking about?
Yes.
Yes.
Yes? Yes, Philip? Then in
Yes.
order to do that, we did the same thing in question number 1, exercise number 1. We said that when we want to do that, we said that we can think of a property that we say that a to the power n over m is essentially a to the power n. It's going to be the squared, it's going to be the square root which is going to be m here. You remember this one, huh? I'm going to use the same property for this function. I'm going to do what? Literally, I mean that I'm going to just start from the same function. And I say, I write it. Oh, I just almost collapsed my laptop. I say it's going to be the log, huh? Now, what I'm going to do, where is my ruler? Oh, there it is. I'm going to read this as a log, and I'm just going to write the function. The function, what was the function, guys? It's x4, y, z to the power 3, correct? The whole expression is essentially inside the parentheses, right? And the power is going to be 1. Because the power 1, it means that it's doing nothing. It's neutral. Huh? It does nothing. Then if I want to use this property, it means that this one is essentially going to the which power, guys? Use this property to simplify this. What is going to be the power then?
1/5.
That's right, 1/5. Gloria and Philip, did you understand what happened?
Yes.
Yes.
Are you positive and understood it? You're sure?
Yes.
Yes, Gloria?
Yes.
How about you, Philip?
Yes.
Yes, and Rose, you said that. That's great. Now, I'm at this stage. Still, I cannot use property number 6 because I do not have f of x, which is x to the power 4, and y to the z power 3 free. I still have them inside the parentheses, which this is locked by 1/5. It's a kind of a prisoner. We have to remove it from the jail. What property you recommend, guys? I free these functions from the lock of 1/5. What property, guys, you recommend me? Huh?
Property 3.
3?
Yeah.
You mean this property that if you're driving a Lamborghini, when you have a hat, the wind blows your hat off and it falls behind the Lamborghini, huh?
Yes.
That's right. So true. Then the thing which I'm going to do is this. I come, okay, right now I have the power 1/5. It becomes equal essentially to what? It becomes essentially equal to, you see, I'm writing 1/5, which is the power to what? Log of the whole function. The function is going to be x4 divided by z cube. Yes? Everybody's okay so far?
Yes.
Yes.
Yes, Philip? Awesome. And now, guys, when you look back again, you see that, congratulations, the function which was as a prisoner inside the squared root, after 2 operations becomes free. You see, it has no square root, no powers. You see that? You see this function is acting like free? And now I can use property number 6. Property number 6, which it said that if 2 functions are divided, you can just, decompose them into the difference of the 2 functions, the log of 2 functions with the same base, huh? I'm going to do this one. I'm going to use property number 6 for the right-hand side. What's going to happen? I'm going to write 1/5. Let me put this aside. It seems that this marker is almost dying. It doesn't write properly. I'm going to write 1/5, which is the power, huh? Everyone sees what I'm writing?
Yes.
1/5.
Yes.
times what? Times it's going to be the log of x4 to the power 4 minus the log of what? yz cube. And I can now close the parentheses. You see, guys, be careful. 1 over 5, it's before the parentheses that it's acting on those logs. Be careful, huh? Does it make sense?
Yes.
Awesome. And now, I can still continue further. What can I do? If you start using from properties 6 and 5, because normally always we prefer to use properties number 6 and 5. Which property I can use now in either of these ones from 5 or 6 to see I can simplify that further.
Property 5.
Property 5 on which?
The second term.
You mean this one, huh?
Yes.
That's right. That's right. Thank you. Because guys, what's going to happen? The thing is that we always think of using property number 5 and 6 first. Whenever those properties are not going to be used, we continue with the other properties from 1 to 4. If I look at the second term, I see that I can use property number 5 because I have two functions y and z to the power 3. They are multiplied together, then I come to decompose them into two terms which both have the log of the functions individually. Then what's going to happen? I keep my power, which is going to be 1 over 5 here, huh? And I say it's going to be the log of x to the power 4 minus the look at minus is going to be there. Another parenthesis, it's going to be the log of y plus the log of what? Z power 3. Correct? Parenthesis closed. You see that, guys? Any questions so far? You see what happened? This log is decomposed into two terms, two logs. And I'm careful, I put the minus sign before these two terms. Correct?
Yes.
How about you, Gloria?
Yes.
How about you, Philip?
Yes.
Awesome. Then as a next step, what can I do, guys? What property out of those 6 ones you can use here at this stage? Property?
Property 3.
Say what?
3.
3. That's right. Because first of all, I look at it, I see in these 3 logarithms, I cannot use property 5 or 6. When I cannot use these properties anymore, I search from property 1, 2, 3, or 4. I see here, I have these functions, which they are wearing some hats, you see? Which it means that you can put them, the wind is gonna blow them away. It means that it equals to what? I have 1 over 5, still there. I have now 4 times the log of x minus the log of y. I'm going to use also take minus inside. Yes, guys, I'm going to take minus inside. Also, it gets minus to the other term. Minus, I have 3 because that's the hat of the other function, log of z. And the parenthesis closed. And essentially we're done. Guys, does it make sense? Any questions so far from the beginning till here?
No.
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 Sorry, I can't hear you. Gloria, do you have a question?
No.
Rose, do you have a question?
No.
Philip, do you have a question?
No.
Everything is fine?
Yes.
Yes.
Fantastic, fantastic. I'm so glad to hear it. Okay, I think we have one more left, huh? This function, the number 4. We are gonna finish this, then we finish the class. Anybody is done with this exercise? Who is done?
Uh,
Rose, are you done?
yes.
Yes. How about you, Philip and Gloria?
Yes.
Are you done with this function?
Not yet.
Not yet. No worries. I give you 1 minute to take a look into that, then we do that together. Okay, let's do that together, then we finish the class. What is this function? This is the log of a ratio of x plus 1, y squared, square root of z. Correct? Okay, guys, if you just want to start from here, you help me to just show me the steps. I look at this one, which of the first 5 properties which I learned, 6 properties which I learned is going to be relative to this one? When you look at it, when you want to demolish this logarithm, which one? You start from properties 5 or 6 normally. Which one is going to be relevant here?
Number 6.
Number 6, because you have a ratio of the function, you want to break it, huh? Then becomes what? Then essentially I can write it as this. Becomes the log of the first function, x plus 1. I know it's going to be minus or plus. Minus log of y squared square root of z. Okay. We are at this stage. I again look at the result which I have. Again, I search into the terms to see if I can use properties 5 or 6. If yes, it's okay. If no, I go to the other properties. Guys, when you look at these two terms, logarithm, can you use properties number 5 or 6 still?
Yes.
How?
Is property number 5.
Where?
The first term.
Property number 5 on the first term.
I
Let me show you property number 5. That was a mistake which I always made it when I was at your age. Guys, property number 5, it means that when two functions are multiplied
oh
in front of one log, if they are multiplied, you decompose them into the sum. It took for me almost a couple of years to eventually learn this one. And for this one, guys, look at that. In front of the log, there are two functions, but they are summed. You see the difference?
oh yes.
Yeah. Then as a result, property number 5 on the first term is not valid because they are not multiplied. X and 1, they are summed. For property number 5, I need them to be multiplied into each other. You see f of x times g of x, right? Then property number 5 is not valid on the first term. But how about the second term? I have y squared times square root of z. Can I use the property number 5 on this term?
Yes.
Yes, guys, or no?
Yes.
Yes.
Awesome. What do you think, Gloria? Can I use property number 5 on this term? Gloria, are you there?
Yes.
Can you use property number 5 on this term?
Yes.
Yes. Then what does it mean? Then it means that I can write the first term as the way it is, log of x plus 1, and it's going to be minus. Philip, you please help me to write this term in terms of, I should say, property number 5. What should I write? I put the parentheses. I see two functions are multiplied. I put them as a sum of two logs. Can I write like that? I say the log of the first function, am I right? Plus, what is the next term, Philip?
Square root 2.
The log, huh?
Oh.
This is z, square root of z.
Oh.
That's right. Then I can close the parentheses. So far, so good, Philip.
Mm-hmm.
Yeah? Gloria, do you have any questions?
No.
Rose, how about you?
No question.
Awesome, awesome. Okay, I put equal. Guys, can I continue further or no, everything is done? Can I use properties number 5 or 6 or no?
No.
That's right. There is no terms that I can use property number 5 or 6. Then I continue with the other properties, 1, 2, 3, or 4. Which property, guys, do you think is going to be relevant here?
3.
3, that's right. Because I see someone is wearing a hat. Then it means that I can keep the log of x plus 1, where it is, becomes minus 2 times the log of y, correct? What's going to be the next term, guys? What do you recommend? Minus the log of the square root of z. Should I write it like that? The log of square root of z. Do you think this is correct?
Yes.
What do you think, Rose?
I think the log square root of that can be 1/2 log that.
Uh-huh. How about you, Gloria? What do you think?
I think it's right.
It's right. Okay, nice. But how about this, guys? If I write log of square root of the z, write it like that. I said that. It becomes the log of z to the power 1 over 2. Can I do that? Because the square root of something is the z to the power 1 over 2. Does it make sense to you, Gloria and Philip?
Yes.
Yes.
Yes? Then can I think as 1 over 2 as a hat and remove it before the log? Can I do that? Am I authorized to do that? It becomes log of x plus 1 minus 2 times the log of y minus what, Gloria? What should I write? You see, I have 1 over 2 as a hat for the z. Can I write 1 over 2 of the log of the z? Can I do that, Gloria?
Yes.
Are you sure?
No.
Gloria, look at that. Philip and Rose. I had log of the square root of the z, correct?
Mm-hmm.
I know that the square root of the z can be written as z to the power 1 over 2. Can you see that? Can you see this term in green?
Yes.
Yes? If that's correct, I can use property number 3 in order to remove 1 over 2 before log of z. Property number 3. Does it make sense now?
Yes.
Yes.
Yes. How about you, Gloria?
Yes.
Yes. How about you, Rose?
Yes.
Oh, actually, you said the answer. Yep, that's going to be then. Then can I continue it further or no, it's done. I cannot use any of those 6 properties. Seems I'm done, huh? That's right.
Yes.
Because I cannot use any other properties from 1 to 6 to simplify these expressions, huh? Then I'm just going to put this inside this one. And essentially, I cannot do anything. Guys, any questions on these exercises?
No.
Everyone is fine?
Yes.
Awesome. Philip, how about you?
Yes.
Rose,
Yes.
any questions?
No.
Gloria?
No.
Okay, thanks. Guys, I'm not going to give you a homework for tonight because we had the late sessions. And but I give you the homework for tomorrow. I tomorrow post the homework. Tonight you can just have some rest. I'm going to finish the class now. If you have no questions, then I see you tomorrow by, I should say, 11:10 a.m. Huh? Okay.
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 Awesome. If you have no questions, I see you guys all tomorrow.
See you tomorrow.
Thank you. Have a good night, Philip. Have a good night, Rose. Have a good night, Gloria.
You too.
Bye.
Bye-bye.
Bye.
Bye.